So this is example 17 from 9.2, and this is a exponential word problem. We've done some of these in 9.1. However, we used our graphing calculator to find when we had an exponent in the power. So this time instead, we are going to use logarithms to solve it now that we know how. So starting with the first two, these are the two classic examples of finding out what a population is when it's first happening. So we're plugging in t equals 0 because 0 days have passed. And then part B asks you after a certain amount of days, what will the k value be? Those are two very common examples when it comes to a question like this. So the radius of a fungus on a tree can be modeled by where t is the time in days since the fungus was first observed. So we have r t equals 0. Okay. Obviously, anything times 0 cancels out, right? Well, not cancels out, it's 0. And then 2.4 to the 0 power is 1. So we are left with 5 centimeters is the radius of the tree or the fungus on the tree. So now what we're going to do after 4 days, the radius is 8. Find the value of k. All right, so let's plug in those two parts. So 4 days and the radius is 8. So 8 will go in for r. 2.4 k and then 4 days. Okay, so this one, we have our variable k up in the power, so that means we're going to have to use some logs in order to solve this out. So starting off, we are going to divide by 5. So we have 8/5 equals 2.44k up top. So in this one, we're going to go ahead and do log to both sides now that our base is the only thing on the right side in order to bring down the k on a non-power level. So we're going to do a log there and do the same thing to the other side. And that's going to allow the part that I need to solve to come down. So let's go ahead and keep going. So we have log of 8/5 equals 4k times log 2.4. Okay, almost done. So I'm going to divide by everything that is not a k, leaving it on the right side. And then we're going to punch this into the calculator. Be careful. I would put some extra parentheses around that when you plug it in, and we'll see what we get. So after typing it all into the calculator, you should get a k value of 0.134. All right, let's go ahead and answer this last question. We have calculate how long it will take for the radius of the fungus to be 10. So we're going to plug that in for r. And we're actually going to use the answer that we got from part B. So the k value that we found was 0.134. Okay, and that's going to go in for k. So 0.134, and I'm going to use t because we want to find out how long it will take. Now, normally, if you were to do this in the graphing calculator, you would graph out y equals 10 and y equals 5 times 2.4 to the 1.134t. But this one, we're going to go ahead and solve it using logs again. So divide by 5 to start. It's very important not to distribute the 5. Do not do that because you have to use your PEMDAS rules. right? And that has an exponent attached to it, so we cannot times those two. So we got 2 equals 2.4, 0.134t. Okay, to bring that t down, I have to log both sides, and those can come down now. So let's see what we got. Log of 2 on the left, 0.134t times log 2.4 on the right. Okay, leave everything, or leave all, leave the t and move everything else. 0.134 log 2.4 needs to be divided out to their side. 134 log 2.4. So that's gone, that's gone, that's gone, that's gone. And we're just left with t and put parentheses around that guy. So let me calculate this real quick. Log of 2 divided by 0.134 log of 2.4, and we have our time, 0.854 days. Nope, that's not right. I think I plugged something wrong into the calculator. I just double checked it. Hang on. That's what happens if you forget some parentheses. There we go. 5.9 is what it should be. I forgot to put parentheses around this part when I divided.